Hi all, welcome back. Today we are going to discussing a new chapter, magnetic effects of electric current. Magnetic effects of electric current of class 10th. The chapter name is magnetic effect of electric current. I think all of you are ready. Okay. For example, assume this marker as a current carrying conductor. So through this conductor the current is flowing. Okay. So this is a current carrying conductor. Then we placed a magnetic needle. What is magnetic needle? The magnetic needle contains a iron piece. The magnetic needle contains a iron piece. We placed a magnetic needle here. Magnetic needle here. Then current is flowing through this conductor. We placed a magnetic needle here. Then what happens? We can see that the magnetic needle deflects. The magnetic needle deflects. Do you know what's the reason? Why the magnetic needle deflected? Why the magnetic needle deflected? Now we are going to learn what's the reason for the deflection of magnetic needle. Okay. The current carrying conductor produces magnetic field. Produces magnetic field around the conductor. Once more I will repeat. The current carrying conductor produces magnetic field around the conductor. That's why the magnetic needle placed here deflected. Why? A current carrying conductor produces magnetic field. A current carrying conductor produces magnetic field. Okay? Do you know which scientist discovered this phenomenon? Do you know the name of the scientist discovered current carrying conductor produces magnetic field? Do you know the name of that scientist? Do you know? And that scientist is Hans Christian Ørsted. What's the name of scientist? Hans Christian Ørsted. Hans Christian Ørsted discovered the current carrying conductor produces magnetic field. So in this chapter we are going to learn more detail about magnetic field and its characteristics. Okay. So next we are going to learn detailing about magnetic field lines. Magnetic field lines. Okay. Before that, I like to ask you some questions. I think all of you know the shape of a bar magnet. What's the shape of a bar magnet? It's like a rectangular shape. It have two poles. A bar magnet have two poles. What are they? North pole and south pole. North pole and south pole. It's already learned in previous year. Okay, it's already learned in previous year. Okay, so assume it is a bar magnet. It is the north pole. It is the south pole. Okay, it's a bar magnet. It's another bar magnet. This side is north pole. This side is south pole. This side is north pole. This side is south pole. North pole, north pole. So, do you know like poles repels or attracts each other? Like poles attracts or repels each other. Like poles repels each other. Like poles repels each other. So unlike poles attracts each other. Unlike poles attract each other. Unlike poles attract each other. For example, south pole attracts each other. North pole repels each other. South pole also repels each other. Okay, let's learn how can we draw magnetic field lines of bar magnet. How can we draw magnetic field lines of bar magnet? Okay, okay, next we are going to learn about magnetic field lines. Okay, first let's draw a bar magnet. A bar magnet looks like this. This is the north pole of the bar magnet, and this is the south pole of the bar magnet. Okay, north pole and south pole. We already know around a magnet there's a magnetic force experienced. Around a magnet there's a magnetic force experienced. For example, if it's a bar magnet, we can experience a magnetic force around this bar magnet, and this magnetic force moves in the form of a line. It moves in the form of a line around the bar magnet, and that is known as magnetic field lines. Magnetic field lines, which is present outside of a bar magnet. Okay, so let's draw the magnetic field lines in a bar magnet. Yeah, it's the magnetic field lines around a magnetic field lines around a magnet, around a bar magnet. You can see again here we can draw so these curved lines around the bar magnet is known as magnetic field line. Magnetic field line. Okay, from this diagram it is clear that magnetic field lines travel from north to south. So in the outside of bar magnet, the magnetic field lines always moves from north to south. But inside the bar magnet, the magnetic field lines moves from south to north. Outside and outside cases. In outside, the magnetic field lines travels from north to south, and in outside the magnetic field lines travels from north to south, and in inside south to north. Okay, inside south to north. That's why the magnetic field lines looks like curved lines. That's why the magnetic field lines looks like curved. That's why the magnetic field lines looks like curved. Why the magnetic field lines looks like curved? Because outside of the bar magnet, the magnetic field lines moves from north to south, but inside south to north. That's why magnetic field lines looks like curved. Okay. One more question. Do you know magnetic field is a vector quantity? Magnetic field is a vector quantity. Why? Because magnetic field has a specific direction. The magnetic field has a specific direction and magnitude. Magnitude means value. The magnetic field has a specific direction and magnitude. That's why magnetic field is known as vector quantity. Magnetic field is known as vector quantity. Okay. Magnetic field is a vector quantity. Magnetic field is a vector quantity. Magnetic field is a vector quantity. So in this class we discovered who discovered the current carrying conductor produces magnetic field. It's Hans Christian Ørsted. Then we study the magnetic field diagram of bar magnet and its characteristics. That's all about today's class. So all of you prepare notes and study well. If this class find useful to you, then surely share this video class to your friends. Okay, so let's see in our next class. Thank you.